Good afternoon. Welcome to come to today's Meetup event. My name is Cindy. I'm one of the organizers of Atlanta IT Meetup Group. And Mongshu, she is my co-organizer. So for this Meetup group, our goal is trying to build out and provide a platform so that more and more technology and the knowledge can be shared and learned from here. Also, people can connect with each other and also build up their, expand their professional social network. So this summer, we prepared 3 events for you. So in June, which is today's event, we will have Eddie, who is from UCB Pharmaceutical, and he will give us a topic of user machine learning technology to predict the virality of YouTube videos. In July, we will have a chief data scientist who is from Mikasen. He will give us a topic about AI and AI automation, and also he will talk about how the AI will replace our future jobs. So I think that would be a very interesting topic. And in August, we invite a speaker from LexisNexis Retail Solutions. He will give us a hands-on workshop about front-end 101. So in this summer, let's grow together. Right now, I think I will just go ahead to give the time to Eddie and let him to introduce his background and start our presentation today. So welcome, Eddie.
Hello, everyone. My name is Addy Wade. I'm currently a data scientist at UCB Pharmaceutical. I have a background in computer science and a master's in industrial engineering. I've worked for IBM for a few years as a systems specialist, and I also dabbled in project and product management for Siemens Industry. And I've been in analytics and data science for about 3 years. So before I jump into the topic or the project that I'm getting ready to present you, I'd like to conduct a fun survey. How many people in the room are doing data analytics or data science in for their profession currently? Excellent. And how many people in the room have experience programming in Python? Awesome, great. And how many people have played around with pandas? The Python module, not the panda sanctuary in Chengdu. Okay, excellent. So sounds like we have some experienced members in the audience. So if any hard questions come up, we'll have some other professionals that can help me out in case I can't answer the question. But let's jump into the topic for today. Now this is a personal project that I did almost a year ago. And this was along the lines of, some of the very basic type of projects that you could do with machine learning, going out, finding some data, and then doing some simple models and looking at the output of the model and assessing your model, looking at the metrics such as accuracy, precision, recall, etc. So has anyone done a data science project in their spare time? Anyone? Yeah? 1, 2, a couple people? So for those type of, in the data science industry, like we have those kind of data sets that are out there and that are readily available, that are, if anyone wants to try to pick up data science, they'll go out and they'll find some data sets like the Titanic data set, right? That's one that the data science industry knows about. The Titanic data set, maybe the Boston housing data sets, maybe some data sets from Kaggle competitions. The flower data set is also a popular one. So when I picked up this project, I wanted to do something interesting. I wanted to collect some interesting data. I didn't want to use Kaggle data. Usually that data is very clean, in a very clean format. you don't have to do that much pre-processing or cleaning of it because they hand you the data in a very clean format. In the real world, that's not very realistic, right? You know, the data is not going to be in the correct format. You're going to have to look for and select your features. And that's really the fun part in the creative side of data science when we get into it, right? When people talk about data science really a science? Maybe 50% of it is a science. Perhaps the mathematics, the coding, the statistical models, the hypothesis testing. That's where the science comes into data science. But on the creative side, you have less scientific methods such as feature selection. And that's part of where your domain knowledge will come in and be invaluable, right? So let's jump into this project and talk about what I was aiming to accomplish with my little project and how I did it. So here are the topics we're going to cover. Problem and objective statement. We'll talk about the tools I utilize, talk about the data collection and pre-processing, some visualizations in EDA. And the way I did my project, there was both numeric data and unstructured data or text data. And I did 2 models. I actually did 3 sets of models. Right? I did modeling on the numeric, the text, and then combined the numeric and the text. And we'll conclude on some things that we could consider for next steps. So the problem and objective statement. Can everyone see the slides okay?
Very good.
Very good. It's always important to spend a lot of time understanding the business problem from several perspectives. And this is a multi-dimensional type of problem. You can think of a problem from several perspectives. And the first thing that I wanted to do was I wanted to predict the virality of the YouTube videos that I did. I did a random search for different words. It's not wholly random, by the way. It's just a biased search. I had my son give me 20 keywords to search for, and I downloaded the data through the Google API, and it returns I think 50 rows of data at a time through the Google API. And it's different data. I'll show you what the data looks like so you can get a sense of that. But just to clarify, because the virality of a YouTube video, what does that mean? What is a YouTube viral video? Does everyone in the audience here knows what a viral video is? When I refer to a viral video, it's kind of a new term. Everyone knows what a viral video is, right? So a viral video, in case anyone doesn't know, is a video that is a tremendous hit when it comes out. It's like a video comes out and everyone is going to flood to that video and watch that video. It's a popular video, in other words, right? Very popular video. And this popularity is obviously subjective, right? You can have a video that gets a certain number of hits, and you can define this metric for how popular it is. And what are the ways that this project could be useful? Well, from a marketing perspective, if you're a YouTube marketer, you can increase brand awareness and reach 10 million. You're trying to reach 10 million views within a certain time frame. This is just an arbitrary date, an arbitrary metric, right? Or if you're from a YouTube perspective, YouTube had the problem several years ago regarding people hacking their view counts. They want to maximize their view counts so they can get more ad revenue. Well, you can put a model in place. If this particular video is not a viral video, is the view count, there's a possibility that it could be getting hacked and have an inaccurate view count. And that would mess up YouTube's marketing strategy, right? And then my objective, this is just a personal objective for myself, create a supervised learning model with roughly 60 to 70% accuracy. Again, this is a personal project, just an arbitrary metric to reach, right? And these are the search words, right? I did a search for Siemens, and some of these words came from my son, and he gave me these ideas to search for these words. On the right-hand side, you're going to see some of what the data types look like through the Google API. And I'll do, there's a brief explanation. If you really want to see what the data dictionary looks like, Google publishes that on their website, and you can click on it here to see a data dictionary, right? And you can see what all of these features mean, right? When you go into do a data science project for yourself or for a company, it's very important to define and have a clear understanding of your data dictionary, right? We're going to study these features, possibly do some engineering on them to come up with the final features that we're going to pass into our model. Pre-processing was needed to be done. So let's jump into some code real quick. And I'm going to jump back and forth between my Jupyter notebook and my PowerPoint presentation. So just bear with me. So as I mentioned, we read in the data through our pandas. How many people in the room are dealing with Spark and big data analytics? Anyone dealing with Spark? Okay, excellent. So that's good to know. After we read in the data, we can take a look at its initial shape. And because this data is so small, I can open it in Excel. That's the beauty of working groups. I can open it in Excel. That's the beauty of working with data on the local machine. We don't have to deal with distributed systems and clusters. But you see, this looks like it's going to give me a headache. These are the search words and everything. Look at all this data here. How do you deal with this? Are all of these going to be useful features in our data science model? Probably not. So this is where the feature selection process comes in here, right? You have to look at this data and determine, is this data going to help us predict the view counts for my video? Probably not. And it turned out, and for my project, it was that roughly these 46 or 48 features, a lot of it was not relevant towards making a prediction for my model, right? So, jumping back to the code, we read in the data, take a look at the shape, those 43 features that we just saw, and we can look at the columns, we can look at those data types, just D types there, just some EDA, and again, like I said, this is not, when you're working inside the notebook, this is just exploration. These are personal things that you're going to look for. It's not code that's going into production, so I apologize if some of the comments are not clear, but I'll do my best to explain what's going on. I'm looking at value counts to determine if this is going to be a useful feature, okay? And you can take a look and look at all of the value counts and look at the distribution of this to see if this is something that's going to be useful. I think and you can see here, I said too many different values of channel IDs, not enough data to make this meaningful, so I'll exclude. So when you work on your own projects, you'll go through the same process. You'll look at the data, you'll do some exploration, you'll do some counts, you'll look at the variation in the data. So I'll open it up to a question for the audience. How would you do feature selection? Can anyone in the room name some different methods to do feature selection? This is a creative exercise. There's really not too many wrong answers. Anyone want to share? Yes, sir.
Can you do correlation?
Absolutely. You can do correlation. You can look at the correlation between your feature and your target value. And I actually did that. There's some statistical tests you can utilize, such as Spearman's correlation coefficient, to look at the p-value, and that's obviously a good way of looking for correlation between one of your features in your targets. In fact, I'll scroll to that code down below. Again, this code is available on GitHub, on my GitHub. So if there's a cool graph you see, if there's something cool that you get from this presentation, you can go to the GitHub and copy the code. And as I did here, I looked at how the like count. What is a like count? Everyone know what a like is on the YouTube video? Is when you click that little button on the YouTube video that says thumbs up. That's a like. So there's obviously going to be a correlation, right, between how many likes there are and how many views the video is going to have, right? So the outcome, you can see some code here, to calculate my p-value, and I utilized Pearson's correlation coefficient, and the like count and views are correlated, so I rejected my null hypothesis. So again, that is one way to do feature selection. Okay, I'm going to scroll back up and continue. So, what's another way to do feature selection? And it's okay if no one wants to raise their hand. I will share with you some additional ways of doing it. Anyone else want to share a feature selection process? Yes, sir.
Using
random forest to do the feature importance.
Yes.
Like.
Absolutely. That's another great suggestion. You don't have to use random forest just for modeling purposes. You can use a random forest to select your features. And once those features are selected, if you don't want to use random forest for whatever reason, you can feed those features into a logistic regression model, right? Don't have to use a random forest. Here's some other ideas I'll throw out, right? Percentage of null values, right? As you're exploring the data, if you've got a bunch of null values in your data or a bunch of zeros, it's probably not going to be a very strong signal for your model. Another thing to look for is variance, right? If there's not a lot of variance, if you have in your data just a bunch of, let's say the number 5 appears a bunch of times, and it's just all 5, there's no variance in that case, right? That's not going to be a very useful feature. You can probably get rid of that type of feature. Those are a couple of ways to do feature selection, and also domain experience is critical as well, right? This is not something you can learn from a textbook or even something that someone that's not familiar with the industry can share with you. If you work in a certain industry, you have to be knowledgeable enough about that industry to come up with some creative features on your own, right? You got to really think about your problem. So, back to my project on the ranking system. So this is just an arbitrary way I set up the ranking system, and you're probably wondering, why did I select these particular ages and view counts of 10 million or 5 million or whatever I have set there? I was actually trying to get my balance. I was actually trying to get my target variable more balanced, right? Do you guys understand that process? If I had set, because I don't have that much data, I only have 1,000 rows of data, if you recall. I had an issue with my data set, my target variable being imbalanced. So my machine learning model was actually having a very hard time training on the data, because a lot of the target variable was 0. Some of the classes were 0. So I tried to narrow this down. And why did I use the belt system? Why did I use this coloring system? I practice martial arts. I practice Brazilian Jiu-Jitsu in my spare time. So this was just a fun way for me to rank the videos. So what would be the lowest ranked video in my system? What color? White, the white belt video. So a white belt video would be someone like me going on YouTube and posting a video of myself trying to play the piano, right? That's not gonna get a lot of views. A black belt video, maybe Marshmallow video, Alan Walker video, BTS, maybe Saturday Night Live, maybe funny videos like and vacation. You can think of what kind of popular, very popular videos that can reach that that 10 million or 100 million view count within a certain number of days. And that's what it is. So tell me, what type of problem is this in terms of binary, in terms of my target variable? What type of problem, what am I trying to do here? Is it binary, multi-class? Multi-class, I heard multi-class, right? This will be a multi-class classification. And how many classes? Can you count? How many buckets do I have? 5. Multi-class classification. So my machine learning model is going to predict a YouTube video into five different classes. That's my goal, right? So are you guys getting a better sense of my project now? Yeah? All right. And you can see, I try to do a balanced job. There's a number of videos that were no ranked. No rank, what does no rank mean? Well, no rank means they didn't meet white belt or any belts. So I apologize. That's actually 1, 2, 3, 4, 5, 6, because we start from 0. No rank would be 0. So it'd be 0, 1, 2, 3, 4, 5 would be the ranking system. And I just dummy variable it. I just set these equal to 0, 1, 2, 3, 4, 5. And that would be that's your target variable, right? That's what you're going to feed into your machine learning model. All right, let's keep going. Let's talk about. Let's take a look at some visualizations. Okay, hold on. Before we do that, okay, here's a pie chart of the belts. That's a nice visualization. Visualizations are important in data analytics. Not too many pieces of the pie, right? You want to try 4 or 5. If you got greater than 4 or 5 slices of the pie, probably a pie chart's not going to be your best choice for visualization, right? So I was right at the limit. I think this is okay. Let's jump back here. We talked about this. So the top 10 black belt videos. This will be fun. Let's see. I mentioned marshmallow, right? Oops. I mentioned marshmallow. Hopefully you can see that. Dude Perfect. I don't know what that is. That's something my son put in there, right? Dude Perfect is apparently a very popular YouTube channel. Funny Cat and Dog. Another marshmallow video. So, Ariana Grande, that's a music video. Music videos are very popular videos, apparently, right?
How old are you, son?
My son is 11. So he has a lot of fun suggestions for search words, right? So I got a quiz. I'm going to test you guys. Someone on a piece of paper or on your laptop, if the name of that data frame on that very right-hand side is DF, and you see the column names right there, and you know what the target values are. I told you the target variable, the target value for black belt video is equal to 5, right? Remember that? How would you write the data engineering or data analytic code to return that in pandas? Try to think about it. I'm going to show you the answer, but this is the slicing and dicing, you can do in pandas, and it's very powerful. And this is, more along the lines of data analytics and data engineering, but we know as data professionals, data engineering is really 70 to 80% of our jobs. When we get into a data science project, running a data science model, choosing your hyperparameters, that's maybe 10-20%, but data engineering takes up a lot of time, a lot of thought time. So I'm going to tell you the answer to my own question. Let's jump back to my code. So here's the code. Write this down if this is interesting. If you want to find out the top 10 videos or the top 10 anything, it could be any field. Like if you work in pharmaceutical industry, your top 10 customers, your top 10 drugs, your top 10 products, right? You work in retail. Who are your top 10 customers or whatever, right? This is the code for it. In the data frame, localized title, view count. These are the two columns we want to pull up from our data frame, and we want to sort it by view count in descending order. And we want the top 10, only the top 10. And of course, you can change this code around. If you want top 20, you can change that number here, right? So, some slicing and dicing. Quick slicing and dicing lesson for us for data analytic purposes. And this is a very important part of the job. Whether you're a data engineer, a data analyst, or a data scientist, the first thing you should be doing, working on, is getting insights into your data. That's probably some of the code, whether you're doing it in PySpark or using whatever tool, you're going to be doing some form of this, right? You're going to be getting some kind of insights into your data and providing those insights to your business. So what is your business going to do? They're going to be able to take some actionable item out of that. Oh, these are the top 10 customers. Well, I'm going to send those customers a gift or something like that, right? You can do something nice for them. Okay, let's jump back to the presentation real quick. Let me see what else is on the list here. So visualizations. I'm a fan of the bread and butter visualizations. As data professionals, you guys may have heard of some other tools out there such as D3JS, SHAP, Line. These are all different tools to visualize data. The bread and butter, as we call it in Python or in the data science world, Matplotlib, right? Have we heard of Matplotlib? Seaborn. These are the most popular. So it depends on whether you're a left brain person or a right brain person. I have mentors in the data science industry that will never touch SHAP, Line, D3. They won't program anything outside of what they're familiar with in Python because they're more left brain. They will say they'll leave. They don't care they can provide information from the visualization. But do they really care if it's, a very polished Tableau-like presentation? No, they're more focused on the information, right? So it depends on whether you're left brain or right brain. But like I said, box plots and these kind of things, what you're seeing here, this was all done in Matplotlib and Seaborns. And the code's there, you can look at it. I'm not going to spend too much time going into the code for this presentation. But if you see something that looks like you could use, obviously the code's there, and you can apply it to your own projects, right? I like this graph. This is a correlation graph. The gentleman back there mentioned you can do a correlation graph to look, or looking at correlation coefficients to do feature selection. Yes, absolutely, right? But for this type of project, it's kind of simple. We know that if a video has a high comment count, if a video has a high like count, it will we know that it's going to affect the view. It's going to be a strong correlation with the view bucket, right? So we see some interesting correlation with these features here, around here. And you're looking at around this area here, right? The comment count, the dislike count, the like count, the view count, this is all going to be correlated with our view count. And you see some features that are less important, right? Category ID, that's not as important. We don't see as many colors, it's a little darker there. Whether or not a video has closed captioning. Closed captioning are the words that appear at the bottom. That's not going to appear. A theory, a hypothesis you might have is a video that offers closed captioning maybe will have more view counts because it can appeal to a wider audience. Maybe some users have to be able to read those closed captions, right? These are just theories, but what we can look at. Let's jump back and look at some code. As I mentioned, I did my project in a number of different stages. I pulled out the number, the numeric data, and ran a model on that. And then I took out the text data and ran a model on that. And then for the final phase of the project, I combined the two, and I got my best performance that way. Obviously, there's more than one way to skin the cat, right? If you give a data scientist the same project, they're going to come up with 20 different ways of getting to a solution. There's more than one way to do it, right? So let's take a look at some code. After I did my EDA and did the graphs that you looked at, and I pulled out my I pulled out the numeric data. Well, what were some of the models I ran with, right? What did we learn here? It looks like logistic regression was used. Multi-class, multinomial, right? You see some keywords here. I'm not going to get too deep on the detailed process, train test split, and the exact step-by-step procedures, and we don't have time to get into all the metrics such as precision, recall, F1. Those are kind of like dedicated subjects that you can, if you're interested in learning more about how to evaluate your model, then that's something you can spend some time on studying, right? Logistic regression. So, really what I was looking for my models was a good accuracy score and mean squared error. I was also looking at mean squared error, right? The precision, recall, F1, and support scores are available there, but whether or not you want to use that for your project, it totally depends on what the measurements are, what the requirements are for your business, right? There's a great analogy I like to think of. If you work for the TSA at the airport, you want to have you're going to have high recall and low precision, right? Because you don't want to allow the chance of one terrorist going through. That's why every single person, almost all, randomly people are getting selected for the pat-down, right? You want to have high recall and low precision in that kind of scenario. So that's just an analogy to keep in mind. But it's going to be different depending on, like I said, your business requirements. Sometimes accuracy is the most important metric, and that's okay, right? So these are just tools, right? All of the things I'm sharing with you right now, they're tools that are part of your toolkit, and you can use them at your disposal, obviously, right? Let's look at some results. Numeric modeling results. That's kind of hard to see. Okay. So, while I was doing this project, I was taking notes and recording the results in a separate notebook. Call it a data science journal, call it a spreadsheet. It was a spreadsheet. But you'll want to do this, right? Anytime you're doing an experiment, and that's really is in essence what data science is. Does a data scientist going into a project like this know all of the best hyperparameters for their random model, for their GVM? No, they don't know that, right? And they're going to do some k-fold cross-validation to see what the best hyperparameters are. They're going to try to play with the number of estimators. Perhaps in your random forest, you can play around with those settings. But each time you run it, you're going to record down your results, right? That's what we, as good scientists, as good engineers, we have to do. We have to take good documentation of what we find, and you can see the results are listed there. And again, you can see some of the notes that were written in the model. A lot of the things we do in the industry when we're working on projects, we kind of follow this format and looking for whether it's a feature dictionary, data dictionary, we have some written notes about the performance. So specific to my project, for the numeric values, I was getting very good results. 69%, that's not bad. That's not bad. My model's predicting with that roughly 70% accuracy. That's pretty good for, you know, just running it through the model. But it's gonna be not too groundbreaking here, right? This is like count, view count, things that are fed into the model, and there's going to be an obvious correlation. If a video's got a high view count, it's likely it's going to have a high like count and other type of comments. It gets a little bit more interesting when we look at the unstructured data, text processing. Okay, this was where it's a little bit more challenging, because why is it challenging? Someone want to speak up and talk about the challenges of dealing with this type of unstructured data? Anyone want to share? What is that? Expensive word? Cleaning the data, yes. Cleaning the data. The process of cleaning the data is obviously a task. And also, at the end of the day, when you're feeding your data into your statistical model, into your mathematical model, and that's all it is. The machine's not learning anything, right? There's a mathematical function in there, and you're feeding data in. What's the problem? If I try to just pass in these words into my model, it will return an error, right? Because these are, the computer thinks in zeros and ones and numbers. You cannot just pass in this into my model and expect an output. So we call this a transformation. We have to transform these words into numeric values in order for our model to do the mathematical optimization, right? The computer, if you just pass this in, is not going to know what to do with this by itself. So let's take a look at some transformations. Let's go back to our notebook and jump into model pre-processing. Here we go, pre-processing in EDA. Okay. Word modeling. While I'm pulling this up, someone name me a couple of transformation methods for transforming this type of data into. Can someone name me some models, some methods, some transformation methods? All right, I'm going to share what's going on here. Okay, dimension handling. So, like I said, I had 3 columns of string text at the end before. These are the features I finalized on. My search word, my title, my description, and my tags. Well, think about that. This is a YouTube video. This kind of makes sense, right? Your description, your tags. Everyone know what a tag is? When you create a YouTube video, you can put buzz keywords in a list, and these are tag words. Your title is obviously going to be an important signal, right? And the search word. So look at what I'm doing here real quick. I'm just concatenating it, putting a space between it, and it's returning my concatenated string into a single column. This is one way to do it, right? So I have a single column like this, and what are some of the ways? I wish I could write on a board, but it's okay. So I'll name you some, right? Count vectorizer, right? TF-IDF vectorizer. So just before I go, count vectorizer is kind of like a one-hot encoding process for your words. If it sees the word Siemens, it'll assign the words for that word a 1. Everything else will be a 0, and that's the one-hot encoding process. You get a bunch of 1s and 0s out of your words. With the TF-IDF vectorizer, which is another part of the scikit-learn module, it takes into account term frequency. So that the mathematics there is term frequency multiplied by the log of the number of documents divided by the number of times that the word appears. So it takes into account how many times this particular word appeared in my document. So there is a little bit more sophistication with TF-ID Effectorizer. TF-ID Effectorizer is a little bit more popular. I prefer using that more than Count Vectorizer. And I use both in my model. I want to demonstrate, right? Some other popular transformations that you can that's used is word to vec. Has everyone heard of word to vec? Anyone not know word to vec or heard of it? Yeah? Okay. Well, word to vec was introduced by Google a couple of years ago. It's awesome. If you want to talk about how to do math with words, you can take the word king and subtract the word man. So these are just strings, and you can get the word queen as a result. So, and it shows in vector space. You can plot some interesting relationship. It gets to the relationships in the words. The downside to word to vec is that you require a lot of data to train on, right? Those type of relationships that is going on in the back end that's established through the mathematics, you need a lot of data in order to get a successful word to vec model. But it's a very, very cool way to transform the words. Won't get in too much in depth on that, but I'm just giving you some ideas. Some other ideas for word transformation, fuzzy wuzzy, global vectors, etc. Yeah. But the NLP space is, natural language processing is very, very, you can do a lot of creative things. Let me see if I can get to an interesting part of the code I can share with you. Okay, and then this is not too interesting. Oh, this is cool. This is cool. Count-based features. Here we go. Counting the number of tokens. The number of tokens is just like how many separate strings or words you have in your entire dictionary, right? And when I'm referring to dictionary, keep in mind that I only had 1,000 rows of data. This is not a lot of data. This is, people talk about big data, this is small data. 1,000 rows is small data, right? So not a lot of data to train on, but some interesting features. What are some interesting features you can get from the data? You can get the count-based features. I'm trying to find the code for my count-based features. I think it's right here. Here we go. So, why are all these box plots? Why did I put so many box plots here? Because, can someone tell me what I'm talking about when I'm saying count-based feature? What do you think I'm talking about? Anyone have any idea? It's okay, I'm going to share with you. So, if you recall, there were three or four columns of strings, right? Count-based features is looking at essentially the count, anything that you can count within the string. So, if you have a long title versus a short title, that's a feature, right? This long title has 30 characters. This short title has 10 characters. Which one do you think is going to be a black belt video? It's interesting, right? I don't know. I want the data to tell me. I want the data to tell me. And you see, I did this. I repeated this. This is applying. This is just some Python code to apply length. Anytime you see this length, it's doing some type of counting, some code to calculate the number of uppercase, the number of lowercase, the number of punctuation marks that are used. If someone writes a description that's too long, maybe maybe it's too long. Maybe people won't read it. They'll skip over it. If someone puts in too many keywords, too many tag words, that could be affecting the video view count as well. So I hope that gave you a sense of what a count-based feature. Anytime someone mentions a count-based feature, this is what it is. You're counting the number of interesting things in that particular feature. And guess what? You're creating a column. Each of these is a feature for my model, right? And let's look at some of the visualizations. I'm going to show you some cool things. Let's jump to that part. Here we go. All right. Word count in the title versus the belt color. You see, if you have too many, if your title, if you're not giving a good enough, first of all, let's look at the shape. I kind of call this is like an upside down U shape, right? This is like white belt, no rank video, white belt video. They got a lot of stuff. They got even more stuff with blue. And it's starting to trend downward a little bit as you go off here. So what that tells you is you can't have, just because you have a high count of the in your title, high word count, doesn't mean that it's going to make it. In fact, the black belt videos have the fewest title words, have the fewest words in the title. Why? Why do you think that is? Because the titles are more succinct. They're to the point. They have 1 or 2 words in the title. And that's all they need. They don't need to flood their title with so many of these words. Look at some of these words. They have 10 words in the title for these blue belt videos. But guess what? The black belt videos on average here have slightly lower, right? On average. So that was an interesting feature I saw. Description, word count versus belt color. Isn't this cool? The black belt videos had the highest number of word counts in their description. Take a look at that. That's pretty insightful, right? So if you're looking at a YouTube video and it's got a lot of description, that's probably going to help push it to a black belt, maybe. Maybe. This was an example of a discarded feature, right? I didn't see any value in keeping something like this because I didn't see any variance. I didn't see too much variance between the classes. And this is just a count of words in the title that have an uppercase first letter, right? This is something that I discarded. So I didn't need to keep this in my model. I didn't think it was going to improve my accuracy. So I threw this away, right? And you can see a kind of a summary of my count-based features. Black belt videos have fewer characters. Fewer characters, fewer count of words. That's interesting, huh? The strongest videos have the fewest characters and the fewest words. You don't want to read if you go to a YouTube video and you see something this long for a title, you're kind of like, what am I looking at? Well, if you see a title, it's 2 words and it's to the point, well, maybe that'll grab your attention, right? That's the hypothesis here, right? And you can read some of the other notes I made here about the videos. Black belts videos have the highest punctuation count for their descriptions, right? Maybe they're writing some very grammatically correct, sentence structures, so they use more punctuation, right? Maybe they're more grammatically correct, easier to read. If a description is easier to read, people will like it more, right? So that was part of the. This was the fun part of it. The feature engineering, looking at this and picking out some columns to put into my final model. And what was the bad news of all of this? Look at the accuracy. This is just the text modeling, by the way, right? If you take out the numbers and you have the model just try to predict the accuracy based on just the word data, it's not enough. It's not enough. So you see the dismal performance in terms of accuracy for just my text data. And you can see some of the things I tried, right? TF-IDF, I mentioned that, right? I mentioned count-based count vectorizer. You can play with the stop words, stem words. Do people have have you guys heard of stop words? Stop words are just like are just words in the English language that are not very useful for machine learning purposes. Words like the letter A or words like the, T-H-E. Those are stop words. They're probably not going to add too much value to your model, so you can get rid of the stop words. Stem words, lemmatization, gets a little bit deeper into the NLP subject. Stem words and lemmatization are roughly similar, but they're things that you can try out in your own model or in your own projects. For example, the word running, run, ran, and are all based on the root word run. So if you have ran, running, you can try to consolidate all of those different words, running, ran, into a single word of run, or something along those lines. You get to the root word, and that's going to be a stronger signal and a better feature for your model, right? So again, some interesting things to try out and look at on your own. When we got to a final model, I mentioned for my final model, I consolidated both the text data and the numeric data together. And you see, I got the best results from this. Obviously, this is going to provide the best signal for my model to make the predictions. This is kind of obvious, right? You combine something from structured data, something from your unstructured data, and you get the best outcome as a result. And you can see some of the things that I tried with my model in terms of the hyperparameter tuning. So just to help the audience understand, so grid search is a method used in the data science part of the project where you're trying to optimize your hyperparameters, right? And the hyperparameters are things that, such as these variables here that are being passed into the input of your model when you go to train it, so that you can set like the number of estimators and the learning rate, the depth of your tree if you're dealing with an ensemble tree-based tree model. But there are trade-offs, obviously, right? When you start running this code, and if you get a chance to run this code, download the code from my GitHub and run it, it'll take about a full day. It'll take about a full day to run it on your PC, and that's running all the notebooks. So these type of processes take a long time because it's searching through and trying out all of these different parameters to try to find the optimal ones, right? So that's what I said the downside to using estimators. You can see that looks kind of high. This is kind of a high-end estimator. I think realistically in the industry, at least for my field, we go we start with 1, and then maybe we'll gradually go to 600, 700, 800 for a number of estimators. But you will see, what I'm trying to get to is you'll see a trade-off. It's not just you put 1,000 in there, and that's going to be the best case, because it's going to take a long time to train, and you're not going to see that much of an improvement. So what's going to happen is your performance is going to start sloping off, right? So the trade-off there is you're wasting a bunch of time and resources training your model. You got 1,000 estimators in there, but you're not getting any significant improvement in your model, right? So you don't have time, you don't have all day, you don't have all the time in the world to complete your projects in the workplace, right? Your boss needs to see the results, your boss needs to know the insights. So it's good to make sure as you get deeper into data science and you learn more about how to optimize your these parameters, you'll get a good sense of what the parameters in there are best for your model, and that will help you. Okay, conclusion and next steps. So, the YouTube API code is in my GitHub, so I could go back and I could collect more data. You know, the YouTube API limits me to only 50 rows of data per search word, so that's why, you know, 20 times 50, I only had 1,000 there. But I can go back and get some more data. That's always good. It's always good to have more data. You can consider some external sources that could cause virality, right? You can get external data sources, external data tables to look for things that could cause virality, could cause your videos to be sensational, right? And obviously, something else to try would be model stacking. You can feed this outcome of this model to an unsupervised learning problem, which then clusters of black belt videos are sent to user feeds. So think about that. That's what YouTube or Google, they're doing today. What do you see when you open up YouTube? You're going to see the video that's most popular, that's most relevant to your cluster, your behavior, your psychographic, demographic, behavioral cluster. You know, you're the customer because you're viewing the YouTube data, and that video is sent to your feed. So you open up YouTube, you have those black belt videos that are presented to you from YouTube are there. This is one way they're doing it. Obviously, they have more sophisticated and access to other data. Obviously, the user ID is going to be an important feature, but that feature wasn't included in the data that we collect from the API. But obviously, Google has access to that, right? So that's something that you could think of doing, right? The outcome of this model can be fed to an unsupervised learning, and you can look at a cluster model to try and find what viewers segments are out there, what kind of customer segments are out there, and then feed the most popular videos to a user's channel. Okay, that pretty much concludes my presentation. Any questions? I hope everyone learned something.
Yes.
Was it informative?
Yes.
Okay. Good. Thank you.
Can you talk about the overfitting when you do the model tuning?
Yeah, sure.
Your experience?
Yeah. Overfitting wasn't too much of a problem in my particular case. It was, I had a good, obviously overfitting can be a problem where, just to clarify, everyone knows what overfitting is when we're talking overfitting? Okay, I think most people do. So overfitting is a problem where, the model works really well on the training set, but on the test set, it's not going to perform as well. So in my particular case, all the scores and metrics you see on my presentation are for the test data. So I didn't have too much problem with overfitting. It can be a problem, but I would say that because this is just this is more or less a fun project. I didn't see any reason to use any regularization techniques such as lasso regression, ridge regression, and obviously random forest as a model itself. When compared to gradient boosted models, random forest models tend to overfit a little bit less. So you can pay attention, in terms of your model selection. And also ridge regression, applying some regularization techniques to your model to reduce the chance of overfitting. But for my project, I didn't do any of that. I didn't have any problems with that. Yeah.
So you mentioned the user ID. How will you define that? So you mentioned the user ID could have impacted the model performance, right? So can you explain a little bit more?
Yeah, absolutely. So let me show you something. Let me show you the data. The data that you brought up, the point that I ended on. The user ID is not part of the data that I can collect from YouTube. The YouTube data does not share that. It doesn't share the user ID. Okay, hold on. This could be it. This ID here is the user ID. But what I'm trying to say is, I don't know, because there was no variance in the user ID. All of the user IDs were different. So I didn't see enough reason to use the user ID. But as you pointed out, and as I mentioned at the end, if I had utilized user ID, it could definitely could be a strong signal. Of course, YouTube would be Google would be tracking user ID and whether or not you're publishing a lot of high quality videos that get a lot of view counts, and that will be used for their models. I didn't use it for my model. Yeah, there's too much variation. I don't have enough data. That's the first problem. All the IDs here are just random letters. So if I had a lot of data for all the users and all the user ID data, of course, that's going to be a great feature, right? But not for my project.
I have two very specific questions. The first one is, when we do the feature selection, if we check the correlations between features, if we see that two features are very high correlated, usually we want to drop one, am I right?
Yes, you could consider dropping features. If those two features are correlated, that's certainly a decision that could be made to drop one of the features. If those two features are correlated and they're very similar and there's might be not enough value to keep it, that's certainly an option for the machine learning model to drop one of those features. But just be very careful about dropping features. Sometimes there could be interesting things that you could engineer from a feature that's not immediately relevant. Sometimes you have to get creative and think about how a feature could be useful if you just modify it slightly. Such as like the counts, count-based features. That's just an example. There could be reasons why you keep a feature and exclude a feature. But like I said at the beginning of the presentation, that's really the artistic side of data science. There's not a solid rule regarding which features to select. Otherwise, everyone would do it the same way, right? If everyone did it the same way, it wouldn't be a topic, right? It would just be a standard way of doing it. But there's some good tools you can utilize for your feature selection, such as looking at correlation, such as looking at variance, such as looking at null values, such as using random forest for feature importance that you can utilize for your model.
Yeah, that answered my question. Thank you so much.
Okay.
I have a second question is, in my own machine learning model, I have a feature. The value is kind of like high, medium, and low. It is I would say a ranked feature. So if before I put the feature into the model, if I replace the value with 1, 2, 3, I think it's not proper because 3 means 3 times 1. We don't want to give extra information to the feature. But if I take dummy, I will lose the rank, the high, medium, low.
Right.
So do you have another way that can better deal with this situation?
You can, is there rank in the feature? There is rank in the feature.
Yes, like high risk, medium, low risk.
Low risk, okay. Yeah, and you don't want to use 1, 2, and 3 because 3 is greater than 2, 2 is greater than 1.
Yeah, exactly.
But you're going to have to represent it numerically somehow, right? So you could try like -1, 0, and 1. Like you could try maybe a negative value in there to see what the output is. But you're going to have to numericize it somehow. But that would be one option to try. Yeah.
Yeah.
just off the top of my head. Yeah.
Thank you so much.
You're
So
welcome.
I have one comment about this. So I have one comment here about this. So I think it's depends on which algorithm you try to use. If you use random forest or decision tree or gradient boost, it's done later because they are handle non-linear relationship. So it's just from the cartel. But if you use logistic regression, because 3 is 3 times, right? So this is the linear relationship. But for tree-based methods, it's done later. So this is my own opinion.
Yeah, good point. Excellent point. If you're using a tree-based model, because it's based on decision, the decision tree, the ranking of the numbers doesn't make a difference because the decisions made in your tree-based model based on a decision instead of a numeric process. Yeah. Excellent point. Excellent. Very good. Yeah.
I'm sort of just curious about sort of how you deal with the dependent variable at the very beginning. So you sort of transform a count data, which is a continuous variable, into sort of a categorical variable, and that, like in a way, would sort of throw away some information. And in my viewpoint, it's sort of quite important information about how viral a video would be. So I'm sort of just curious about like why you decide to transform sort of the continuous variable into sort of the categorical variable at the very beginning.
Yeah. So the rationale for clustering or categorizing the videos into 5, because I didn't have that much data. Remember, I only have 1,000 rows of data. I only have 1,000 target variables. So if we're dealing with a regression, if I didn't do anything with the view counts, the accuracy is not going to be very good. I'm not going to get a very good performance with my model because I don't have very much data, and I wanted to classify the data in this way so that I can look for specifically videos that are very high performing. Again, this is a personal decision. If you did your project your way and you use the numbers, that's absolutely fine. Your model would just be predicting view counts. And that would be, if that's what the business requires, I want your model to predict, the exact view count. Is it 500,000 or is it 1 million within 2 months?
Because when you predict it in terms of view counts, you can always then transform it once you got sort of the prediction back into sort of some sort of tiered categories.
Yes.
Like
Tiered categories. That was just the personal decision to do it that way. This is called bucketization or binning, right? And it's used quite commonly. And sometimes we have to do that to look at. In my industry, in the healthcare industry, you have to look at age groups. So for my business of selling medicines to patients, do I need to know the exact age of the patient? Probably not. Would I want to know whether she is 30 to 40, 40 to 50, or older? Maybe I have 3 buckets, So it depends on what the business needs are, And this is just what I decided to go with. Yeah.
So I think this is 2 types of questions. So this is regression. Here is classification. So I'm based, like I said, is based on your business requirement. You want it to classification or you want it to regression. So regulation, you will try to predict exactly the number.
Yeah.
Right.
Expand on that a little bit. So imagine I'm YouTube and I want to charge more money to advertise on a Black Bill video, right? I want to charge advertisers a certain cent per click for viewers that view the Black Bill video. I charge less and less and less. It's just a ranking system. If you're predicting house prices, right, that would be a regression type of problem. Just a different problem depending on the business situation, right? Any more questions? Great. Thank you, everyone. Yep.
Thank you so much, Adam. I think that is a very interesting topic, and even if you don't know the technology, but the results is really helpful, right? At least in the future, when you have a YouTube video, you know how to navigate. So thank you so much, Addie, and this is our gift for you.
Thank you so much.
Thank you. And as I said at the beginning, we will have future events. So please mark your calendars if you're interested in it. And also keep following us from Atlanta IT Meetup group, and we will update the information from there. So thank you. Thanks again for all your coming here. And also thanks for today's volunteers. So thank you so much. So, okay, so hopefully you enjoy the rest of the day and the rest of the weekend. Thank you.